Hello and welcome to today's episode where we're featuring leaders in engineering. Today's guest we have is Bruce Cutright. He's the CEO of Geoframe Energy. Welcome, Bruce. Pleasure to have you here.
Yeah, thanks, Sam. Glad to be here.
Good stuff. So let's start off with a bit of on your background. Quite keen to understand your story into transitioning into running a business.
Well, the energy industry is fairly complex. My background, I have a bachelor's and master's in geology and hydrogeology with minors in civil and geotechnical engineering, and went on for a PhD in which I majored in water law and uh, uh, hydrogeology and really the chemistry behind that. That's the educational background. My experience has really been mostly in the field of engineering and the construction, design and construction of everything from the longest extra high voltage DC power line across Central Africa to combined cycle coal-fired, natural gas-fired power plants, hydroelectric plants, and then the last 15 years of my career has been in the field of geothermal energy and renewable energy. So experience counts. You got to have the basic education though to start.
Yeah, there's a lot of experience right there. Yeah, so go into a bit more about what your business does.
Uh, my company, Geoframe Energy, was founded to really focus on developing geothermal power generation. Just a brief background. Sometimes when people say geothermal power, they're thinking of ground source heat pumps. What we do is we drill very deep wells into the hot zones at depth, often several thousand feet, 10 or 15,000 feet deep, and produce hot water that's under pressure, and so it's above the boiling point of water. And we use that hot fluids to flash into steam, drive a turbine that generates power and can provide utility scale power, anything from a few megawatts up to tens to hundreds of megawatts of power generation.
Yeah, I wondered if you could just go into that a bit, because I remember when we spoke before, you were talking about the pros and cons of different energy.
Oh,
I wondered if you could just cover that a little bit.
sure. I mean, the key, renewable energy is obviously an interest that the entire world has been focusing on over the last 10 to 15 years because of the carbon emissions from fossil fuels. Well, geothermal power is a key component of that renewable energy transition. And the frustration is that the focus from the popular focus was really on wind and solar. Wind and solar are great, the sun's shining and the wind's blowing, but the question is, what do you do when the sun's not shining or the wind's not blowing? The availability or the online availability of solar is only about 21 to 24% out of a 24-hour day. Wind at times can be as much as 35 to 40% available, but again, you've got 65 to 60% of the time in which you're not getting any effective power from wind. So the question is, what do you do in the meantime? You have to have baseload power. This is power generation systems that can provide 24-hour-a-day power. The world has normally relied on coal, natural gas, oil to provide that baseload power. Well, geothermal, because it's a renewable energy and it's available 24 hours a day, is a key component of the real transition away from fossil fuels. Nuclear power, of course, is a good baseload power generation source as well. And in reality, it's a renewable energy. But the focus and concern about the waste disposal and potential hazards of nuclear power just didn't allow the development or widespread application of that as much as it could have been. But geothermal is sitting there. First geothermal power plant was about 150 years ago in Italy, and it has the capability of really meeting the needs for renewable energy without the generation of carbon dioxide. Worldwide, there's about, I think it's 15,000 to 17,000 megawatts of installed capacity. So it's a growing resource and is available nearly everywhere.
Yeah. So how does that impact your business then? Is there is there opportunities in that or challenges? I wondered if you could just cover that a little bit.
Well, the challenges are a little bit of public perception because it's hard to bring investors into projects in which they can't see exactly what's happened. It's all underground. You know, the only thing that you really see at the surface for geothermal power is the wellhead. And then from that wellhead, you have the heat exchangers and the turbines and the electrical generators, but that is a very small footprint. And so the whole source of energy is underground and it's hidden. There have been, early in the development of geothermal power, there were what were called the wildcatters, just like in the petroleum industry. Companies that would go out and say, oh, I can drill a hole here. And they'd drill a hole and be a dry hole. They couldn't produce any energy at all out of it. And it was because there was a real failure to understand the systems in the deep subsurface that you need to develop usable power. Now, the deal is that the petroleum industry, 150 years of capital investment in really understanding the subsurface environment, we founded my company on the aspect of taking that technology that the petroleum companies use to define oil reservoirs and applying it to the discovery and development of geothermal power sources. So that was the quantum leap that happened about 10 years ago, 12 years ago. A little longer than that. The petroleum industry developed this technology culminating in the shale gas revolution in 2012. And it was that technology that came out of that really revolutionized the growth and applicability of geothermal power generation.
Yeah, okay. So would you say your business is quite specialized in what you do? Does that create opportunities in itself?
Absolutely. It is very specialized because understanding the subsurface geology, really the petroleum companies, the mining companies, they have been uniquely focused on that area, but the rest of the world really has no understanding of what's going on underground. There was a famous court decision related to the development of groundwater resources, in which the judge said that discovery of subsurface resources is arcane and unknowable, and therefore could not be regulated by law. Well, this was back in the late 1800s. It was an interesting court case, but for the longest time, that was the opinion of the legal world, the political world, that you couldn't really regulate something if you didn't understand it. And so it's only been really in the last 30 to 40 years in which reasonable government policies have been focused on how to manage or how to be involved in the development of geothermal energy.
So how do you see that changing as you move towards the future? Is there any particular trends moving in any direction, or?
The biggest trend is really the desire now, or first the recognition that geothermal energy is a viable resource that can really be a benefit to the worldwide transition away from fossil fuels, and that the policies and government officials, regulatory agencies are now recognizing this is not something that has the potential to cause pollution problems. It has great benefit that can be applied. It's zero or very low emissions of any carbon dioxide, of any other pollutants. When designed correctly, you could put an entire geothermal power plant in a normal parking lot and no one would even know it was there because it's very small footprint and zero emissions. There have been a few cases, and less than a handful, less than 5 worldwide, where there have been adverse environmental impacts by a geothermal project. And for just to set the stage of what most of them are not, there was a project in Hawaii, on the Big Island of Hawaii, in which the developer drilled a well very near the volcanoes that are there, and the fluid that they were producing had hydrogen sulfide in it. So instead of containing that, they were emitting it to the atmosphere. Hydrogen sulfide smells like rotten eggs. The odors flowed downhill over a nearby development, and of course the neighbors were not happy about that at all. And the developer was forced to go back and insert the correct design and gas controls so that hydrogen sulfide wasn't emitted. But that's the rare case. Most of them are basically zero emissions at all.
So you'd say that in general, the government and like legislation is moving in your favour with your business?
That's correct. And the key way that they've treated most government policies is recognizing that the heat that you're producing from underground should be treated like a mineral resource, that a private company or a government agency can come in and develop it, that the limits are able to be defined with the appropriate investigative work, and that protection of that resource should be done in a way that maintains its availability into the foreseeable future. The way that that's handled in most cases now is very similar to how groundwater resources are handled. It becomes a public good, and a common good in which you're a developer from either public or private sources is allowed to develop it as long as there is no adverse impact on neighboring property or neighboring businesses.
So when it comes to, you mentioned what you do is quite specialized. I know we spoke before a little bit about employing people and getting that talent in there. Obviously, being quite specialized, I wonder if you could just talk me through some of the challenges involved with that.
Sure, and this really comes back to us talking about the finding quality staff to come in and help on these projects. Yeah. There are really three different aspects that you look for. The first is the special expertise to first identify and understand what's going on in the subsurface. So those are the people that help you go out and find, where can I drill to produce geothermal power? The second is how you drill, and that's the drilling engineers. And the design of a geothermal well is very different than the design of a water well or a petroleum well. And then finally, there's the surface facilities, and that's the mechanical engineers that are designing the turbines, the electrical equipment, the power line connections, those things. So those three aspects are what you look for. And you really can't find people that cover all three aspects, so you look for the really top-notch geologists or geophysicists that can find the resource in the subsurface. There's a decline in employment by the petroleum industries, and many of those geologists and geophysicists that are coming out of the petroleum industry are looking to move into geothermal energy. It takes a transition. And a short comment, petroleum, natural gas, and oil deposits basically sit at the very top of a reservoir, and they're bounded by faults or some type of geologic structure that limits the size of that resource. What geothermal is looking for is really the hot water that is below the oil or gas deposits, and that reservoir is generally of a much, much greater volume. And so that's why you can produce geothermal power for what amounts to in perpetuity. It's renewable. Those hot fluids continue to flow into the area that's being developed. There is a constant heat flow from deep within the earth that constantly heats those deep brines that you produce to produce power. So that you have to re-educate the petroleum geologists to work there. And then the engineers that design the wells, a common well for a natural gas development might be 4 inches in diameter. What we look at is a much larger diameter deep well to produce geothermal power. And that's a special expertise. And of course, the ability to drill horizontally, which came out of the shale gas revolution, opens up a much longer reach for the well for for the reservoir to provide fluid to. And what you want is the highest flow rate that you can produce out of those wells. So again, the petroleum engineers are looking to develop a very little tiny window, and the geothermal engineers are looking at designing wells that will maximize flow from the deep reservoir. And then finally, the power engineers at the surface, coal-fired power plants, natural gas-fired power plants, they're looking at a heat source that is in the range of 750 to 1500 degrees Fahrenheit. We're looking at a hot geothermal source might be 350 to 500 degrees Fahrenheit. So our net source is much cooler, and so your delta T, which produces the energy, is smaller, and you have to design the heat extraction and power generation systems to account for that.
Yeah, so that's, yeah, they're quite
good. You got to find
experts.
Good geologists and people that can quantitatively, and then enjoy their work too. If what you're doing, if you can't have fun in what you're doing, then there's no sense doing it.
Yeah, definitely. So let's transition a little bit into the business side of things. Obviously, you're very specialized in what you do, with a lot of experience. When it comes to running a business as well, and the skill sets around that, what would you say? What are some particular wins you've had in the business, or successes, or some insights that you can share from that?
Well, the hardest thing for us to do is to bring in the investors to fund these projects. As a company, you don't raise capital for yourself. You're raising capital for each different project so that the investors can see this is what their investment will return to them. And again, it's the educational process. That's the hardest hurdle to get over, to explain to them that geothermal works, that we do understand what's going on underground, and then you've got to have a customer for it. Now, this is something that you and I talked about before. It's the customer side of things. The customer sees, oh, wind and solar, gee, they're cheap. There's, free wind and free sunlight coming out of the sky. Why don't I go that way? Because it's the cheapest source. And this is where the online availability that we mentioned when we first started talking comes into play. If your solar system is only producing power about 25% of the time, to use a round number, that means that 75% of the time, you've got to find some other resource. Okay, the cost of solar, just looking at the investment, the capital required from, let's say, a megawatt of power generation from solar, results in the need for a solar project to have a return of at least 2.5 cents per kilowatt hour that it can generate. Okay, but that return is only occurring over 25% of the time. So it doesn't produce any power anywhere else. From a utility standpoint, I've got to have, let's say, a natural gas generating system or a geothermal generating system. If I only want to buy power from that baseload energy source, well, that cost, where it might be able to provide power at 4.5 cents a kilowatt hour because you're shutting it down or constraining it, that baseload source has to increase their cost of power provided to cover the cheap power that you think you're getting from solar or wind. Okay, now, if the solar or wind doesn't have access to a baseload source, then the common perception is, oh, we'll just add battery backup so we'll store the power during the day. All right, numbers for you. Let's say we build a 100 megawatt solar plant, okay, and I want power 24 hours a day though. So now I have to increase that 100 megawatt solar farm to be 400 megawatts in order to have 100 megawatts of available power, because that extra 300 megawatts, first it has to go to charge batteries. Second, it has to go to replace the lost power on each recharge-discharge cycle. That lost amount of power, basically the efficiency of the batteries, ranges from a low of about 78% to a high as much as 30%. So where I think I'm getting cheap solar power at 2.5 cents a kilowatt hour, it's really costing me 4 times that, or about 12.5 to as much as 15 cents a kilowatt hour. And this is what the utility is seeing when they think about building a utility scale solar plant. Okay, if you look at natural gas is profitable at about 3.5 to 4 cents a kilowatt hour. Geothermal is profitable at 4.5 cents a kilowatt hour. But that's 4.5 cents for the full 24-hour period. So there's no additional charges that you have to have in either any of the baseload sources. But if you constrain those baseload sources in order to have solar and wind incorporated into that, you're actually increasing the cost of everything else, and the real solar and wind power cost is anywhere from 4 to 5 times that amount. And batteries by themselves are 5 times the cost of everything else. So it all comes down to economics. So when you ask the question, what about the business side? I spend most of my time educating potential power purchasers of what the real cost of power supply is. And everybody, just to clarify, people speak of a megawatt of power or a megawatt of solar. What's missing is the megawatt per hour or a kilowatt per hour of power. And people don't mention the time factor when they speak of power supply. So you always have to remember that's a hidden variable that you put in there, and then suddenly things look very different when you consider the time of power. Okay, sorry, I hope I haven't taken too long.
No, that's interesting. I wondered if you could just expand on, because having that level of technical expertise, how do you educate people who don't have your background, and you're trying to educate them on, look, what we provide is a very good service. It's better than the alternatives. How do you actually go about that education process?
Well, yeah, you really have to just start from the simplest thing. I'll give an example of, you have 100 kilowatt light bulb. Right? The old incandescent lights, that was a common size, the 100 kilowatts. All right, so if you have 10 of those, that's 1,000 kilowatts. All right, but that's 1,000 kilowatts per hour. So if you're really looking at a generating capacity, if you look at a battery, if you have a 1 kilowatt hour battery, all that battery is going to do is run one light bulb for 1 hour, and then it's gone. So for a 1 kilowatt hour light bulb, and if you have 10 of those, so 1,000 kilowatts or 1 megawatt, then you've got to have 10 batteries that are going to meet that. So I try to reduce it to things that you can see in front of you, and how that works. The greatest issue that we're dealing with now, and I think you and I briefly mentioned this, is that the huge power demands that these data centers and the AI data centers and what they call the AI education data centers are requiring. They used to come to us and say, well, we need 10 megawatts of geothermal power 24 hours a day. Easy problem, you can get that anywhere. Now they want to have 100 to 250 to 500 megawatts per hour of power to sustain these data centers. And here in the United States, there's over 12 data centers that are being built right now under construction that are requiring over a gigawatt, which is 1,000 megawatts of power supply. And it's not just power supply, it's what's called N3 power. You have to have redundant power supply in case any of your primary power supply systems go offline. Geothermal generators have the best operating history of any other source. Nuclear power, you have to take those offline for maintenance. Natural gas, coal, all of those have to come offline for maintenance. A different level, but geothermal can provide power 97 to 98% of the time. Well, what that really means is you've got to have 2 or 3 standby generators that can then pick up the load when you take one generating unit offline for maintenance. Increased cost. The real trick is looking at, you can't build power plants fast enough to meet these demands that the data centers are requiring. And right now the focus, and in fact, you and I mentioned this before when we were talking, Sam, that there's a big focus now on looking at these small modular reactors, because you can come in with a nuclear reactor that can serve anywhere from 30 to about 300 megawatts without any real adverse impact. We didn't talk too much about the cooling supply that has to be provided for those that are usually water cooling, but that's where the big emphasis now is. The Bill Gates investment program has got a big program in central Wyoming that they're trying to build small modular reactors there. These reactors are available, and just for your audience, the key thing, if you think about the U.S. Navy, the British Navy, French Navy as well, on the nuclear submarines and nuclear ships, these are basically small modular reactors, and we've had those operating safely since 1957. So there is a case history of how these small fission reactors can serve these power needs. But again, there's many public concerns about having a number of these units in areas that may very well be subject to seismic events, earthquakes, adverse storms, flooding, all of these kinds of things. And they will probably be implemented, but there's room to be concerned.
Yeah, that's interesting. I wondered if you could just go into that a bit more about what your predictions of where it's going to lead in the future. Is it with energy and these small modular reactors, or any technical changes? I know you mentioned AI. Like, where do you think it's moving towards?
Well, I do think there's been a lot of discussion that natural gas was the bridge to the future, and the bridge from where we are now to where we're going was really to serve as the sustaining source of power generation until we had either widespread small modular fission reactors or the ability to develop fusion reactors came online. And as you know, fusion has always been one of those alternatives that was 10 years in the future. Well, now maybe it's only 7 years in the future. We are getting closer. The research that's been done with the tokamak reactors and some of the other fusion reactors are being quite successful, but these are huge, complex engineering problems that are very expensive. And so the hope is there that they'll fill the gap someday, but that someday, from a practical standpoint, the best guesses for the shortest time are 7 to 10 years. The more realistic and educated guesses, I would say, are that we're at least 10 to 20 years away from practical commercial scale fusion reactors. So natural gas needs to be the solution. For carbon emissions, there are well-designed carbon capture systems that can pull the carbon dioxide out of the exhaust gases of natural gas generators, and geothermal. And geothermal really has the ability to solve all of the problems that are perceived to be related to fission or to fossil fuel power generation, and certainly to be the solution for all those areas where small modular fission reactors might not be applicable.
Yeah, that's interesting.
So there's a future prediction for you. I don't know if I'll live long enough to see whether they come out to be true, but it'll be fun to watch.
Yeah. So I'd like to go a bit more into your business. Where do you think, what are like areas that you think you're doing particularly well in?
Well, our expertise was the ability to find hidden geothermal energy resources. We used some very specific computer techniques and algorithms that were proprietary to our company, that started out of the development of the mining industry in Southern Africa, where the idea was if you have some information in one spot, and then you have just one point of information farther away, you can predict what's in between those points with a certain level of confidence. And that ability, as more and more data was gathered worldwide, those predictive analytics, which people now call artificial intelligence, but really it was the predictive analytics and the equations that we used to really define the resource, or to find where resources are. That was the entry that our company had when we came into the business world. We've now been very successful at that, and secondarily, because it's also there's a big focus now on critical minerals for all, battery technology, computer technology, the rare earth elements, the platinum group metals, lithium for batteries. All of these underground oil fields, brine resources that are deep underground, high-strength saltwater resources that are left behind from the last ice age and before. Those brine resources contain high concentrations of minerals that can be recovered using chemical extraction techniques. And so our business is really transitioning to be not just energy, but also energy and minerals. We're producing, or working on, a project right now that will produce enough lithium carbonate to meet the entire lithium demand of the United States by 2030. So and realistically, we will be about 1/3 of the cost of the present technology that's being used in South America and Chile and Argentina. China is using hard rock mining to produce theirs. Their cost is $10,000 a ton more than what our cost is. So even though they may want to control the market, and if they subsidize their approach, they will not be able to drive their supply down to be able to compete with what we can produce here in the United States.
Yeah, fair enough.
So energy, that's the solutions.
Yeah. So where do you see, based on that, where would you like to move the business towards?
Well, we see the next step is to combine desalination with the waste heat from the geothermal power production, because water supply is always been a key element. The whole flow of producing these deep salty brines that are hot, extracting that heat energy from them to produce base load renewable energy, extracting the minerals from that salty brine that really support and fund the growth of our technology society. And then finally, the environmental concerns, those deep reservoirs where we produce this brine from, we can then take the reject brine from the desalination plant and put that back underground into these deep salty reservoirs with absolutely no contamination, no release of contaminants at the surface, and no damage to the shallow groundwater drinking water supplies, because generally we're a mile below where those shallow drinking water supplies are. So that whole integrated system is the approach that I'm calling it, or have been calling it, and that's what my entire team is focusing on, is don't just look at energy, but look at energy and minerals and water, and all of those together with no environmental impact. That's the transition where I see the whole field of geothermal power going, and that's where we're trying to lead the way.
And where do you see the challenges in doing that?
It's education. Again, people, it's always easy to be a critic. And so the first critic says, oh, you don't know what's going on underground, you can't do this. The second critic says, oh, if you're going to develop these underground resources, aren't you going to cause earthquakes, seismic events? Well, now we have to have answers to every one of those questions. And so we do. We look at all the studies that were done on induced seismicity, ranging anywhere from the high-level waste disposal that occurred in Colorado during the 1960s and caused seismic events, to the deep injection of saltwater disposal wells in Oklahoma and Arkansas and Texas here in the United States. You have to have the real focus of understanding, why did those efforts go wrong? Why did they produce adverse effects? And then finally, it's the whole issue of environmental. The geothermal addresses everything. The zero emissions in the atmosphere at the surface, the very small footprint counter to the large footprints required for solar and wind, the constant power supply in contrast to the intermittency of wind and solar, the zero emissions in contrast to the natural gas, coal, oil, biomass, all of those, and the ability to provide freshwater, drinking water supplies at a cost that is about 2/3 of the standard reverse osmosis price of desalination of seawater. So underlying all of this is an economic advantage above or basically below the other sources of just individual elements of that, individual power supply, mineral supply, desalination.
Education.
Yes, yeah.
Yeah.
You have to have, it takes good quantitative scientists and engineers to make all of this happen, and then innovative financial people to understand how the return on an investment really can benefit the broad investor that is looking to make a difference in the world.
In your experience of running a business, what are some leadership traits that you've thought are important for running a business, things that you've picked up on?
The classic engineering personality is perceived as being fairly unfeeling and arbitrary, and that's a quality that you cannot have. You have to understand people, and people are a problem, just like everything else. Everybody has different life pressures that occur behind the scenes of the 8-hour employment day. And to get people to come and work in the environment that you want, you have to first create an environment that is not, or that's comfortable to work in. And then you have to understand that people vary. They have good days and bad days. And I think the most important quality is you got to listen to them. And the .com companies, the big companies that created these recreation rooms and all those kinds of things, I'm not sure that really increases productivity, although they'll swear that it does. But the whole idea is I think there has to be a separation between work and private life. And that's a good thing, because you don't want to spend 24 hours a day working, and often it's an advantage for people to be able to, I have my private life, I can go to that. That's my sanctuary, and this is my challenge. I love my work as a challenge. One of the things that I have encountered in my own experience is that you hire somebody and they come out of school or they've been working in the environment. And so this is a new challenge to them. And many people are afraid to take a challenge. And that was one of I always worked with my young employees to sort of build their career. But I found that it was often an experience where you'd give somebody a problem that they hadn't seen before, and they'd quit. Oh, I can't do that. I got to find somebody else to do it for me. And I'd say, no, you can do it. You've got the basics of information. Sit down, think about it. How are you going to come up with that answer? And they'd jump ahead. Well, I don't know what the answer is. Well, find the steps to get to where that answer is. And that mentorism, the ability to sit and convince a person that don't run away from a problem, figure out how to get to the solution that you need to get to. And, there's a good employee will really see that as, this is fun. I love being challenged. That's what you look for. The employee that says, I can't do that. I just want to do this. Well, this that has fences around it is no fun. You never learn. If that's all you want to do, then my company is not where you need to be. And I say, you need to go someplace else where you can find a challenge or find happiness. And so what I look for is really that ability not to find somebody that knows everything, but to find somebody that wants to know everything and wants to figure out how do you get there. That excitement the intellectual challenge and the hard work that it takes to get there. It's scary, but then you see these people that show up at 5 o'clock in the morning and they're just, 100% concentrated on getting to the end. And then they glorify and look at the solution I came up with. You look at the most innovative companies in the world right now, and these are the ones that are really driving it. I have a personal story to tell you. I serve on what's called the Astrogeology Committee with the American Association of Petroleum Geologists. And on that committee, there are several of the NASA astronauts that we've worked with. Harrison Schmitt was the only geologist to walk on the moon, and a colleague of mine. And Harrison describes the early days of NASA in the United States as being that kind of environment where the average age was like less than 30, that there were these young people that were just so excited about pushing the limits of knowledge and the limits of achievement forward. And that's what made the NASA, the Apollo program, all of the different research and things that went on in NASA during that period of time so incredibly successful. And he says now Harrison Schmitt is in his 80s, says now if you look at NASA, the average age of NASA is in the 50s. So the young, innovative, energetic engineers aren't there anymore. They've all grown old, and they get tired as they get older, and they don't have that enthusiasm to work all that many hours or to really work hard to solve these problems. So I think what we as a society have to do is find ways to support this enthusiasm in whatever field people are in. The enthusiasm that this is something that I'm doing because I enjoy it, and sometimes they become very wealthy doing that. But working for wealth is not always the appropriate goal. It's the idea that working to make a difference in whatever field you choose, and the excitement that yes, I can be successful at doing that. That's what I look for.
Yeah, that's some good insights. I love that how you talk about investing in developing your employees, and that's going to create a more fulfilling environment for them and somewhere they want to be. And it's going to increase their enthusiasm for what they're learning. Yeah, I love that, what you just shared.
The continuous education is important. I always supported my employees. I call them my kids, my employees, because most of them were younger than me. But the idea that the peer respect is often what's very, very important to them. To pay for their membership in the professional societies, whether it's engineering or science or whatever specific field they're in. Make them be part of that broader group beyond the boundaries of the company that they're working for. And then pay for regular educational courses. Let them define, I want to become better in computer programming was a common thing, or I want to become better in, I had one guy in matrix mechanics. He wanted to learn that. I didn't have a lot of use for that, but it made him a better mathematician, which did help in the problems that he was solving. Societal involvement, working with local charitable agencies, absolutely. You have to support that. That's part of the community involvement. One of the fun things I did is I built a low-head hydro plant for a Presbyterian hospital in Central Africa. They were relying on diesel, to run their x-ray machines and autoclaves and other stuff, so they could only get diesel about 3 or 4 days a month. But this hospital was on the edge of a river that had about a 3-foot drop in height, and that was enough to drive a continuous little generator to power the entire hospital and all their equipment. So you have to look for opportunities to make a difference.
Yeah, definitely. Well, thanks for your time today, Bruce. You're clearly very passionate about what you do and very knowledgeable. Where can people reach out to you if they want to find you? What's your website or social media?
Yeah, absolutely. The best way to get a hold of me is through our website. It's geoframeenergy.com. Actually, maybe geoframe-energy.com. And there's a contact us there, and that goes directly to me. So be glad to answer any questions and follow up and encourage anybody that has an interest.
All right, great. Well, thanks for your time today, Bruce. Take care.